Okay, we're in section 7. Though it's going to be lecture. I'm just going to review what you've done in the past with limits. And so, for example, a limit like this over here, one thing you might have done is you might have graphed it. All right. Now, someone says, well, graphing is really tough, but this skill set is something that you learn in Math 119. You could certainly have graphed this in Math 119. I'm going to speed the process up, though. And what I'm going to do is I'm going to use a graphic utility. And again, you're more than welcome to use any graphic utility you like. So let me do that. And what I did was I graphed out, the function 1 over x minus 1 minus 2 over x squared minus 1. And then what I did, I wonder what happens when you close to 1. Well, over here, I'm looking at it. I'll zoom in for you. And we're looking at a region over here now. Now, someone says, what are you doing? Well, I'm getting close to 1 from both the left and the right. And that's that point I'm interested in. I'm not going to touch the point, but if I'm looking at this thing, I'm looking over here, and it looks like it's going to take on the value about 0.5. So that's something we've done. We've actually looked at a picture, and we've determined that the limit looking at the picture was about 0.5 or 1/2. Right? It's kind of imprecise because I'm not absolutely sure if that's really 0.5 or maybe some other number. So then what do? We also looked at tables of values. Right? Let me go to that. I'm going to do Sage for that. And give me 1 second to get the Sage. I'm going to, try to enter this in here. I'm going to reset. I'm going to set x to be a variable. That variable, again, is going to be x. I'm going to define a function f of x. And that function I'm looking at is 1 minus, looks like x minus 1, minus 2, divide by x squared. By the way, the limit law does not apply to this problem, and that's why I'm doing this, all right? We'll talk about limit laws later, all right? That's when we get to this manipulation and reason part over here. So what I'm going to do is I'm going to take a look at a point. The point I'm looking at is 1, and I want to go to the right side of it, so I can say 1.1, and what do you get? You get that number. Now, if I want to get closer, and I'm still to the right. I always say 3 is the charm. I'm looking at that, and let me get another number. Again, it's kind of hard to me to say what's going on over there, and the fact that it does appear to be getting closer and closer to the number I thought it was going to get closer to, which is about 0.5. Again, you can play with this. She's doing all the work for you. It isn't like you're doing any work over here except typing. And no, that's not really work at this point. But you could keep doing this, all right? And again, if you keep doing it, I'm hoping to start to realize that this is getting closer to 0.5. And now I'm actually exceeded to 0.5. By the way, this isn't a round off error. I would not worry about this so much. I'm asking Sage to do an approximate arithmetic. Now, if you're at the left, let's do this over here. And what's the left of 1? I would say 0.9. Right now I'm seeing that over there, a little bit bigger than 0.5. By the way, if you go back to the graph, you would probably see that as well in the graph. So, right, I'm going to do, 0.99 now. And again, I'm going to say it's getting closer and closer to 0.5. So my picture and my numerical analysis in the picture, I'm going to say that limit looks about 0.5. Right now, of course, this section is not about going back to the past. This section is about going towards the future. And what do they say? Algebraic manipulation and reason. So I'm going to go to the whiteboard. I'm going to go through the algebraic manipulation and reason skills. The reason basically is going back to limit laws, but having full understanding that by using limit laws, what am I basically doing? I'm still looking at a limit. And my limit, I know what it means to me. It means don't touch 1. Well, that makes my life a lot easier. If I'm not going to touch 1, I get a lot of things I can do. Just give me 1 second to get there. So I'm going to point out, if I were doing this problem and someone said, oh, just use the limit law, see what happens. And there's a problem with the limit law. And let me go through that with you. Well, this is the limit of a difference. You could try to do this. Limit x goes to 1. I'm using limit laws now. 1 over x minus 1 minus. That would be limit x goes to 1, 2 over x squared minus 1. Unfortunately, neither of these limits exist, so the limit law doesn't apply. Neither limit exists, and the reason that the limit at the bottom is 0 in both cases. So I'm going to say, gee, I can't use limit laws in that. So what I need to do is I need to erase. I'm going to erase this business over here. I'm going to try to do, what I might have done in Math 100, which is manipulate. And let me go through that with you. And I'm going to write this over here for you. limit x goes to 1, and I'm going to manipulate what's on the inside over there. And I'm noticing it's got a common denominator, x minus 1, x plus 1. Now, if you're struggling with this, you're really struggling with Math 100 level material, and you should go back and review Math 100. Again, it may be a process, particularly if you're not well prepared, where a lot of review is happening for you, which does increase your study time, by the way, because you have to learn prior material to go forward. What comes over here, I'm write down for you, x plus 1 minus 2. All right, let's keep going. I also want to encourage students that need to come by during office hours and we can discuss what your options are. So what do I get over there? I'm just manipulating, just like what I've done in Math 100. Basically just, add those two fractions together. And what do you get on top now? You get x minus 1. Now, what do I know? I know the limit says get close to 1, but don't touch it. If I'm not going to touch it, I'm going to tell you these things are non-zero. So I got another problem over here. If they're non-zero, I got another equivalent limit to write down, and that equivalent limit's going to be, whoops, sorry about that, is going to be the limit, sorry about that, go back to black ink, limit x goes to 1. This would be 1 over x plus 1. Now I can use a limit law. And why is that? The limit of the top is 1, and the limit of the bottom, super simple, is 2. So now, through my manipulation, I know the limit's going to be 1/2. All right. Let me repeat what we did over here. We looked at this. Limit law did not apply to that problem. So what do? We manipulated it. How did we do that? We added those two fractions together, and I eventually ended up with x minus 1 over x minus 1 times x plus 1. X goes towards 1. What does that say? Don't touch 1. So x minus 1 would cancel out because it's non-zero. And then we're left with a problem. We can use limit law. And that's really good. What else did we do? We went to Sage. We used tables of values, computational. And I went to Grapher, and I also did a graph of that. And I'm going to say everything's lining up for me to be a limit of 1/2. Now, here's the problem. In the examples that follow, you'll be faced with problems where thinking is required. I strongly suggest that you think before answering a question. I really do. And when you're faced with like 0 over 0, infinity over infinity, or infinity times 0, or infinity minus infinity, you really need to have to think very carefully. All right. What I mean by this is that if you don't think and you just simply blindly plug in, you're going to get a wrong answer a lot of the time. All right. A lot of the time. We're trying to, prevent that from occurring for you. So I'm going to say numerical and algebraic skills will certainly be needed. What do you need? Prerequisite skills, Math 100, Math 119, Math 120. All right. And now we're in the Math 121, where we're starting to think of limits in a little more rigorous way. All right. So next up will be examples, but we're actually done with the lecture or the presentation related to this section over here. Hopefully, as we do examples, we'll illustrate points that you need to consider doing these problems over here. It's not just the answers we're teaching about, it's the method to get to those answers is what you need to get covered. I also want to recommend certainly read textbooks if you have access to one, and you should have access to a textbook, whether it's a textbook the school is recommending or a textbook that someone else recommended to you. Pretty much all calculus books that I'm aware of address these issues quite competently, certainly better than any lecture could do by itself. All right. So I'm going to call it quits here, and we'll come back and do examples later. Thank you.